In this video, we'll learn about another user-defined type in C called a struct. So if you're familiar with object-oriented programming languages like Java or C++ or Python, you know that in those languages we can define objects or classes that contain both data and also the logic to work with that data. And in C, it's not object-oriented, but we can still define these structs that will group data together, and again, just make our program more readable, maintainable, and just make our lives easier as programmers. So the syntax to define a struct is similar to the syntax we saw for an enumerated type. So we have our typedef keyword, and then now we're defining a struct. So then we say typedef struct, and then inside curly braces we define a number of components for our struct. And so this struct is representing information about a planet. So we have things like an array of characters for the name, so a string here. We have a double, the number of moons, the orbit time for this planet, and the rotation time. So you could imagine maybe I might define a struct to keep track of students at a school that would keep track of their name and their ID and what courses they've taken and how many credits they have and all that. And so you can use structs in a lot of ways. So just like our other user-defined types, we want to define these just below our preprocessor directives, so we can put these outside of main just at the top of our program. And in another video, we'll actually see how to move these out into their own separate file to keep our programs nice and organized in their own files. So to start off, let's see, how do we actually declare a planet? Just like other variables, we can just say we would like to declare a planet T, and let's name it. Ooh, maybe we'll declare Earth. And so we can just allocate memory for it like that. Or we can also initialize a planet. So just like we could initialize other variables in the declaration, we can also say something like planet T. I wish I knew more about planets. I'm going to call it example so that I don't feel pressure to do anything right. Ooh, we'll make it a blank planet. How about that? That's easy. Okay, so this is a planet that's just not going to have any information. In order to initialize it with curly braces, I'm going to need to pass in values for all of these things. If I were to not pass in a value for some of them, they just wouldn't be initialized. I wouldn't know what was there. First I have I don't have my key casting on, but maybe it would help for you to learn Vim better if I put that on, so I'll do that. Maybe move this up a little bit. Okay, so let's see, we have a double, we have an int, we have a double, and we have a double. So what this will do is it's going to make me a planet where name is set to just an empty string, the diameter is set to 0.0, etc. And so we can start to see that that's true by taking a look at these components, and we do that using the dot notation. So let's say I wanted to say blank planet has name, and then I'm going to print my string using my string placeholder, and then I'll say using dot. So if you know other have experience with other programming languages, this might be familiar to you. But to get to these components, I can use the dot operator, and that will allow me to get to any of these with their name. So now I want the name, and that should work out for me. So let's go for it. This is planet. We did not use Earth yet, but that's okay. Oh, and we want planet, not example. Planet. And yeah, the name is blank, so we're not getting anything interesting there, but we can at least see that the dot notation is working. And let's say I wanted to set Earth. Let's say I want to set Earth's moons to 1. It's one that I know. Again, I can use my dot notation, my dot operator, and I would say Earth dot moons equals 1. So now we've been using strings, and we know that they can be a little tricky. So if I want to set Earth's name to Earth, we've got to remember that in order to do assignment for strings, I have to use string copy. So I can't say something like Earth dot name equals Earth. I have to do string copy, and let's see, I think I copy into the one on the left. So I would do Earth dot name, and then I could put my string Earth in there. And so this warning is telling me that I don't have a string copy function, and that's because I did not include string.h. Okay, and maybe we'll keep adding to our program and then we can run it later. So that is how we access these components using the dot notation, and we remember that strings, we need to use string copy. So now let's see how we can also use structs as inputs to functions. So let's say I wanted to define a print planet function. So I'm going to make a function prototype up here. So it's not going to return anything. I'll call it print planet. And it's going to take in a planet T type, and that's all it really needs. And so one thing to note is that we do pass our structs by value, so we can just put in our planet T like that. So it's just like when we're passing like an int or a double or something like that. So now I need to actually define this. So print planet. So I'll call my planet planet. And let's see, I need to print name, and that's a string. And just thinking if I want to do some nice formatting, but maybe I'll first print it and then I'll think if I want to format it more nicely. So how to get to the planet name? Well, we actually already saw that. What do we have here? We have diameter, moons, orbit time, rotation time. Diameter. And then diameter was a double. Change inner word. Diameter. And let's just do one more. Moons. That's a int planet dot moons. So, and let's actually call our function. So we can print planet, and so now I just need to pass in a struct, a planet in particular. So I have both Earth and I also have blank. And let's just try it on both of those. So Earth, I guess we actually never set diameter, so we're not guaranteed that this is 0, but it is 0, that's fine. Then our blank is all 0. Maybe let's just spice it up here and set some things. Let's set, well, we could set, one thing we can see is how, so for string copy, so let's set blank's name to Earth as well, but let's do it by copying whatever Earth's name is. So I'm going to copy into blank.name, I'm going to copy whatever Earth.name is. So now they're both going to be called Earth. Set blank's moons and diameter. I'm going to say blank.moons equals 12, blank.diameter equals 1,000, I don't know, really big. Okay. This is, in the appropriate units, whatever's right. And now we should get some more interesting things printing out here. So, yeah. And if we wanted to just practice our formatting, so let's say we wanted to justify these outputs. So I want my name, my diameter, and my moons, the actual name, to justify. So I don't remember if that's positive or negative, but let's just say that it's positive, and let's say I want that sort of column to take up, I think I'm going to need name. I think the way that I would need to do that is I'd actually need name to take up a certain amount of space. So I think I could do %s, and then I'm going to need to pass in name as a string here. I'm demonstrating this because your assignments ask you to have nice formatting like this. So now I think I need to pad it on the right with some spaces. So I'm not sure if that's negative or positive, but we're just going to try something. So we'll try 10, and then we just need to do the same thing. We're going to say %s, but we're going to give it, we need it to take up 10 spaces, and now we need to pass in diameter as an input. And finally, we need to do the same thing, so maybe I'll just copy it. So I'm just using visual mode, so I press lowercase v, and then I use L to get as far as I need. I'm going to press Y to yank, and then I'm going to press VIW to highlight the entire word. So visual in Word, VIW, and then I'm going to press paste, or P to paste what I have. And I still need to put my moons in here. So let's take a look at this. I don't know if that's going to left justify or right justify. In fact, it did not work at all. Which surprises me because I would have thought maybe we'll just try a -10. Oops. Oh, maybe I didn't compile it. That might be it. Okay. So, well, here's what we learned. oops. So we learned that the -10 is going to pad on the right side with the zeros. We also learned that, of course, this colon is going to be after that, and we might want our colon in here if we really cared about making this nice. I wanted to run it. Okay. So now we see that we've padded this so that there's 10, it takes up 10 total slots, and that allows us to align those names. So we see how we can pass a planet in to a function. You could also return a planet, return a struct, that's totally fine. I realize I don't actually have an example of that planned for this video, but maybe in a later video we'll see that as well. So another thing we might want to do is compare planets, right? Say, are these two planets equal? So if I wanted to compare planets, I might define a function called planet equal. It's going to take in two planets, right? It has to compare them. And now I'll define my actual function down here. So I'm going to need to name these. I'll just call them P1 and P2 for brevity. And now I would like to, actually, let's say I don't return void, I return an int, so it's either going to be 0 or 1. Let's say I want to return, actually I can't remember if 0 or 1 is supposed to be true, but it kind of doesn't really matter. I'm going to say return the result of comparing P1 and P2, and I'm going to do that by saying return, and I'm going to say in here, maybe all fields, all components equal. And so I guess I need to actually define this. So what are all my components? I have p1.name, and I need to check whether p1.name is equal to p2.name, but I can't use equals equals here. I have to use string compare. And then I also want other things to be true, right? So I need p1.name to equal p2.name. I also need p1.moons to be equal here. These are just ints, so I can use equals equals. And then maybe I also want p1.diameter to equal p2.diameter. And I would also need, let's see here, string, okay, yes I did mean that, thank you. And I need a semicolon. Conflicting types for planet equal. Are there? I'm taking in, oh, this one says, this one needs to be int. Okay. So if maybe I'm just doing, in general, I guess let's do, we also need to compare orbit time and rotation type. p1.orbit time, p2.orbit time. Looks like I forgot my and finally p1 dot, I've already forgotten it, rotation time. And I use lowercase gg to get to the top, and I can just press G to get to the bottom. Rotation time. Okay, so let's actually call it, maybe we, so print out equal, and then I'm going to print whatever I get back. So, and now I'm going to print whatever I get back from planet equal of my two planets I have are Earth and blank. It's a little, okay, let's see. And I need a semicolon. I'm just going to actually set values for the rest of Earth's stuff, set the rest of Earth's values, because they're not initialized, right? So Earth dot orbit time. Yeah, orbit time. Oh, equals, okay, 365 days. Earth dot rotation time, 1 day. I guess these are doubles. It'll cast it to a double for me, but maybe I feel happier just seeing that those are doubles. And now let's try and see this works. And okay, I did not put a new line. So first off, I need a new line here to make this nicer, but I think we saw that we got a 0, but now let's just see if Earth and Earth are equal, right? Just a little test. Compile and run. Oh, we did not get that they're equal. So that seems like maybe we have an issue. So one thing that we can find here is that, so string compare is returning us a 0, I think. Let's take a look. String compare tutorials point. So string compare 0 if these are both equal. Another thing, let's see, Boolean 1 or 0. This is sort of, so 0, this is a little fortunate, so, but maybe makes sense with string compare, I guess. So in general, 0 means false, right? And so in our program here, I was kind of thinking that this would give us back a yes, like a true, if they're equal, but actually it gives us a 0, which would be false. And so by putting this string compare in here, I'm not going to get quite what I want, because when p1.name and p2.name are equal, I'm going to get a 0, and so this never will evaluate to true, because I have a 0 in here, which C is then interpreting as false, right? So I actually need to say that this should be equal to 0. And I think this will work now. And so now we got, when we pass in 2 copies of the exact same thing, they are indeed equal. So that is an intro to structs for you. And we'll go over some more examples with structs.